everyone, welcome back to my YouTube channel. This is Lata from Sri Venkateshwara College of Engineering. Today I'm come back with a new topic. Let us see table of content. First we are going to see what is binary tree and binary tree traversal, what is graph and terms of graph. First, let us see what is binary tree. A binary tree is a data structure in computer science that consists of a nodes where each node has at most two children, and it is referred to as the left child and right child. It is hierarchical data structure that is commonly used to implement binary search tree and expression trees. Next, binary tree traversal. There are three types of traversal are there. That is pre-order traversal, in-order traversal, post-order traversal. Let us see one by one. Let us see first what is pre-order traversal. First, pre-order traversal visit the root and then visit the left subtree and lastly it visit right subtree. In-order traversal, first it visit the left subtree, then root and lastly it visit the right subtree. Post-order traversal. First, it visits the left subtree and then right subtree. Then it lastly visits the root. Next topic. What is a graph? A graph is a data structure that consists of nodes and edges. It is used to model relationship between entities. Graph can be directed or undirected and may have weights assigned to edges. They are widely used in various computer science applications such as network design and social analysis, networks analysis. Graph can be represented using adjacency matrix or adjacency list, and algorithms like depth first search and breadth first search are commonly applied to traverse and analyze graphs. Next, direct graph. A direct graph, also known as digraph, is a graph in which edges have a direction. This means that the relationship between vertices is one way. In a direct graph, each edge has a specific direction representing a flow or a relationship from one vertex to another. Next, undirected graph. An undirected graph consists of a set of vertices connected by edges without any directionality. Each edge in an undirected graph does not have a specific direction, allowing connections between vertices in both directions. Represented visually, it forms a network of interconnected nodes without the notion of a start or an endpoint. Let us move on to the next topic, that is weighted graph. A weighted graph is a graph in which each edge is assigned to a numerical value and it representing a weight or cost. This weight could represent distance, time or any other relevant measure. It adds additional information to the structure of the graph, enabling more complex analysis and algorithms. Adjacency matrix. An adjacency matrix is a 2D array used to represent a finite graph. It is a useful way to visually show which vertices are connected with each other. Space complexity. It requires O of V square space, where V is the number of vertices in the graph, making it inefficient for a sparse graph. Edge identification. It's easy to determine if there is an edge between two vertices by accessing the specific element in the matrix. Next, adjacency list. Efficient representation. Each vertex has a list of its adjacent vertex and it saves space. Easy to implement. Simple to understand and use, often used in graph algorithm, and it is dynamic in nature. This can easily accommodate changes in the graph structure. Depth first search. Depth first search is an algorithm for traversing or searching trees or a graph data structure. It starts at the root node and explores as far as possible along each branch before backtracking. Uses its stack to remember where it should go when it reaches a dead end, and it is often used in solving math problems and puzzles. Breadth first search. A breadth first search is a graph traversal algorithm that starts at the root node and explore all the neighboring nodes at the present depth before moving on to the nodes at the next depth level. It is often used to find a shortest path in an unweighted graph. In conclusion, both binary tree and graphs are fundamental data structure used in computer science for organizing and representing data. Each has its own characteristics and applications. In binary trees are hierarchical data structure consists of a nodes, where each node has at most two children, refers to as a left child and right child. They are commonly used for tasks such as organizing data with hierarchical relationships, implementing search algorithms like binary search, and representing arithmetic expressions. Binary trees can be traversed in different ways, including in order, pre order, and post order traversal, each with its own specific use cases and applications. When it comes to conclusion of graph are non-linear data structure consists of a nodes connected by edges which represent relationship or connection between the nodes. They are used to model various real world scenarios such as social network, transportation network, and computer network. Graphs can be traversed using algorithms like depth first search and breadth first search, which help explore and analyze the structure of the graph and find paths between nodes. And this is about binary tree and its traversal and types of graphs. Thank you for watching.